Hi guys, thank you for coming. My name is Mario Fusco, and yeah, as you guessed, I'm not Trisha. Sorry for you. Yeah, I'm here to speak about a similar argument to the one Trisha was planned to talk here. She wanted to give a fresh look to Java using the lambda, so check how you can refactor your code using the new feature of Java 8, and namely the lambda expression. I'm going to do something similar, but with a different pattern. Yeah, pattern is the right word. So who knows this book? Yeah, of course. I started doing this job kind of 20 years ago, and at that time this book was the Bible. Actually, you have to learn that pattern the dirt, and you are not a serious professional if in your code there was at least a strategy together with a factory or an abstract template factory or I don't know what. Okay, so the more you use more and more patterns inside your code, the better you are. I don't want to say that this book is totally negative. It was a great book at the time. And the good thing about this book is that it gives us a common ground, a common vocabulary. I mean, if I had to implement the strategy pattern inside somewhere in my code, and I say to a colleague, look, I used the strategy here, I probably don't need to add anything else, because the strategy became a common thing that everybody is supposed to know, okay? But the problem of this book is that it is totally biased toward a given paradigm, that is the object-oriented one. And at time, it was fine, because object orientation was the cool thing. The problem is that something that is modeled as an object in the book is totally artificial. They are modeling action with that are verbs, that are function, okay? And they are using object to model them. That is conceptually wrong. And indeed, the most important part of this book is divided in sections, and the most important part is the section that is called the behavioral pattern. And I hope that if I give this book today to a student, he will tell me, come on, this is a book about object orientation, and a behavior is a function. So why this book has a section about behavioral pattern? It doesn't make any sense. And indeed today, I believe it doesn't. And this is what I'm trying to demonstrate with this talk today. So what I did is preparing a few very simple implementation following the dictates of that book, and trying to rethink, to rework them under a functional point of view, okay? So I prepared some example, and if you want to download my example, you can just go here, and there will be all my example with both the Django 4 implementation and my own functional version, okay? So let's start from something very, very simple, okay? So that this is probably too much simple, but I'm showing this to reinforce my former point, okay? What is a command? A command is something totally fictional, it's not necessary. What we are trying to model is an action. It is a behavior, okay? And again, we need to wrap that action inside a command to translate the function into an object, because at the time the only available tool was the object-oriented paradigm. Okay? So what I'm doing here, I have this command interface, and then I have different implementation of this command interface. So I have, in my very simple example, a command to log something, to save something into a file, and to send an email, okay? And then what you do is that you create a list of these commands and execute them, okay? This is something very typical. But what's the problem with this? The main problem is that you have a very bad signal-to-noise ratio. I mean, look at the command, okay? The action, the important thing is just this. That's the business logic, okay? But since we don't have the concept of a function, we have to wrap all this stuff inside an object, okay? So let's try to rework this. Okay, as I said, this is, in my opinion, the signal of the command. So let's put it here. Okay, and let's create a function out of this. So I'm making this method static. Why static means that I cannot access the state of the object containing this method. I cannot have pure function in Java. This is the way of doing pure function. And then I can, for instance, rename this. Passing the message, okay, and that's all. This is my command. I translated the command into a proper action. That's what it is, okay? So let's try to create more commands in this case. So we have the save one, and we have the send one, okay. Okay, so then what we can do? We can do exactly what it does here, but possibly even in a more functional way. Okay, so what I'm doing here? Here I'm replacing an external iteration with an internal one. Do you know the difference? This is something that function that Java 8 also allowed us to do, and also it's an important change of the paradigm. Okay, what this thing do? It's doing an external iteration, right? So I'm iterating the list, okay, and I'm guiding the iteration. Let's try to rewrite this. What I can do is something like this. Of course, these are not common, but these are not common, but they are runnable here, okay? Why are runnable? Because if you look at the signature, the runnable is a functional interface, and if you look at the signature of the single abstract method of this interface, it doesn't take any argument and returns void. That is exactly the same thing that my commands do. So what I can do is just doing this. Okay? And that's all. The fact here, the main point here is not that this code is smaller, okay? But even here, it's a totally different paradigm. Here, I'm doing an external iteration. Here, as a user of this API, I'm iterating this stuff from the outside, okay? Here, the API is in totally control of the flow. It's in control of what is happening, okay? So what's the difference here? This remembers me how my daughter Sophia put away his toys, okay? So when she was smaller, when she was younger, I had to guide them, okay? So at the end of the day, if you have children, you know that. At the end of the day, there are lots of toys in the room, okay? And you have to push your daughter to put them away, okay? So what you do is an external iteration. What I did, I said, Sophia, what's on the ground? The ball, okay, take the ball and put it on the box. What's on the ground? The car. Okay, take the car and put it on the box. What else? The doll. Okay, take the doll and put it on the box. Okay? That's what I'm doing. And in this case, I'm saying totally different. I'm saying, take all your toys and put them all in the box. Okay? And in this case, Sophia is in totally control of how to execute this task. Okay? So not only it's easier for me to give the instruction to Sophia to do what I want to do, okay? But since Sophia is in totally control, she can internally optimize what she has to do, okay? So at some point, she could decide to take the ball with one end, the doll with another end, and put them together in the box. So do parallel computation, right? Or she could decide to take the ball before the doll, because the ball is closer to the box. So she could do instruction reordering, for instance, okay? But why she can do this? Because the API, in this case, is in totally control of the flow, and then it can do some optimization for us. Okay, so this is another important difference. Okay, now how I use this stuff? Of course, I can do this. I don't need this command thing. Okay. And now here I'm just passing lambdas. So I can do this. And I can do the same for the other two. So it was save and send. Okay. And then I can do just this. We'll make this static. Okay. And, okay, of course. Okay, and yeah, this is the expected result, of course. Okay, so again, this was something very simple, very easy, I know, but I wanted to show a point, okay? Let's try to do something a bit more complex. I will skip some of them because they are similar. So again, I invite you to take the code example from my repository on GitHub. So I will skip the strategy because it's very simple. Instead of translating a command into an action, now I'm translating the strategy object into a function as well, but it is exactly the same thing. Okay, let's try with the template pattern and give an example how to use this. Okay, here I have a resource, and I want to use this resource. So what I typically do, I create it, I use it, and then at some point I need to dispose it, because otherwise you could have some leaks of memory leak, file pointer leak, database connection, or what you want. But I'm simulating that these operations are risky, so sometimes they may fail. Okay, and of course, if I do this, okay, if they fail, okay, I get the failure, but the worst thing for my program is that I'm not calling the dispose, and then I'm having this leak. Okay, so how to prevent this problem using the Gang of 4 template pattern? I create a template of how the user of this API is supposed to interact with it. So my template is this. Okay, every time the resource is used, you have to create the resource, to do something with it, and then in a finally block, you have to close, to call the dispose to make sure that you won't have any leak, okay? And then you have an abstract method when you describe how you want to use the resource, and then you have different implementations. So here I'm using the resource in some way, and here in another way, and finally I can call this execute on this object, and then I'm safe because the template makes sure that I'm disposing my resource. Okay, but still, even here the signal to noise ratio is quite bad. So again, this is the signal, and we could do something better. So sorry. So let's try this. So what I do is creating the new resource. Okay, and then in the finally block, I want to make sure that I'm disposing it. Okay, and what I should do here? I should do something that allows my user to use the resource, to consume the resource. So I will pass to this execute method a consumer of the resource, right? And then I can just do this. Okay? And now, how I can use this method? Of course, I'm passing inside a lambda the way how I want to use the resource. So I do, for instance, this, and now this is also called the land pattern, because now the framework that I'm creating is lending me the resource. I can use it inside a lambda, so I'm consuming the resource this way, for instance. I can do what you want, use resource or employ, whatever. And now, when I'm done with this, I'm returning back the resource to the API, and the API is making sure that the resource will be correctly disposed for me. Okay, so if I try to run this, okay, this was a lucky run, but yep. Okay, if I try to run this, I may or may not have a problem, but if I have a problem, this simple API that I provided to my user makes sure that the resource will be disposed anyway. Okay? Let's try with another pattern. Also, the observer pattern is quite similar to the template. Now I will use another consumer, and now I'm not consuming a resource, but I'm consuming the event that I'm listening. So it's very similar. I won't go there, but let's give a look at a more interesting example, in my opinion. The decorator that in functional programming is just translated with function composition. Let's give an example. So I have a few functions method that are, let's say, a database of taxes, of function of taxes that has to be applied to a given gross salary to calculate the net. Okay, and what I want to achieve. I start with the gross annual salary, and then I have to divide it by 12 to have the monthly one. And then I have to apply some taxes, okay? But the fact is that I don't know, or I want to give to my user the possibility to apply these taxes in different way. I want to apply certain taxes or not, okay? So to achieve this, with the Gang of 4 pattern, I create this decorator. How does it work? I'm creating this abstract decorator that wraps a salary that has an abstract method that is the apply tax, so is the function, the method actually executed by the actual implementation. And then when I call calculate, I calculate on the salary calculator that I'm decorating. So it's like an onion, okay? I call the same method inside the salary calculator that I'm wrapping, and then I apply the function that I'm defining with the current decorator, okay? So I have a decorator that applies the general tax, another that apply the regional one, and another that apply the health insurance, okay? And then what I do is creating this onion, where the core of the onion is the default salary calculator, and then I apply the general tax on top of it, and the regional tax, and the health insurance. So you can, as you can see, you have to read this from the inside out, okay? And at this point, I can calculate my net monthly income. As I said, what's the advantage of this pattern? Is that if for a given employee I don't want to apply the original tax anymore, I will just comment out the regional decorator, and then that tax will not be calculated anymore. Okay, and then of course I will obtain a higher result. Okay, but if you think about this under a functional perspective, what is this? It's something very much more simple. So let me take this, and for me this is a function that is a double unary operator. Why is a double unary operator? Because the double unary operator takes a double as an argument and returns a double. That is exactly what this thing does. So it's exactly the same thing, right? And now how I can apply taxes to this value? It's super simple. I start from this, that is a function. Okay, and then I add the general tax, okay, and then I add the regional one, and the health insurance, and at this point I can calculate the net. Okay, so if I print this out, I will have exactly the same result as before. And as you can see, I also have the same feature. Now it's super easy. I don't want the regional tax. I leave it out. Same thing as before, right? And this also has the advantage that you don't have to read it from inside out. You read it as it's written, okay? Another thing that probably you may want to do is provide your user to a function like this. So a function that calculate the salary starting from the gross, and taking a varargs function. Okay, so how I can use this method to have exactly the same effect? I would like to have a method that in practice accept the gross salary, and then a varargs of function, so something like that, right? Okay, so how can I implement this method? What I could do is put in all these function inside the stream, Okay? And then I want to create, I have a stream of function, and I have to create a single function out of them. Okay? So it is a reduction operation. And the reduction operation takes two arguments. The reduction operation works on a monoid. Okay? That is a bad word, that is a semigroup with a zero, or is an associative operation with a zero. So what is the zero and what is the associative operation in this case? For instance, let's suppose that we want to concatenate string. Okay? Let's suppose we have a stream of string and we want to concatenate them. The associative operation, of course, is the concatenation, is the plus for the string. Okay? And the zero is the empty string. Because if you add an empty string to another string, you obtain exactly the same string as before. Okay? Now, let's try to do this in terms of function. Okay? The composition operation is and then. Okay? And what's the zero for the function of composition operation? What's the zero? It's the identity function, of course. Because if you compose a function with an identity function, you will obtain exactly the same function as before, right? So I can do this. My zero is the identity function. And the composition operation, as I said, is the and then one, right? Now I have one single function. And what I can do is this. Okay? And I could also print this result. And I should obtain, yeah, the same result. Make sense? Sorry, I didn't say this before, but feel free to interrupt me if you have a question. Okay. Okay, let's try the chain of responsibility. So what I want to do here, I have a file that this file could be of different types. It could be a text file, a presentation, an audio file, or a video. And I want to parse this file, okay? So I have a text parser, a presentation parser, and so on. How I use this set of parser with the gang of 4 pattern? Using a chain of responsibility. So I create this parser, okay? Okay, I define an interface, an abstract class as usual, and then I have different implementations that are my parser. So I have a parser for the text file, a parser for the presentation file, okay? And with this parser, I create a chain. So when I pass the file to this parser, either is a text file and then I'm able to return a result. Otherwise, I pass the file to the next ring in the chain, to the next element in the chain. And of course, if I'm the last item in the chain, it means that I'm not able to parse this, so I will throw an exception, okay? So I use this stuff, I create my 4 parser, I chain them, so I say that the presentation parser is the next to the text parser and so on. So I create this chain of 4 parser, and then I send to the first one the file. This is an audio file, so the text parser is not able to parse it. The presentation parser is not able to parse it. The audio parser finally is good and delete, and then it will produce the result, and the video parser will be never invoked. Okay? Just to give this a run. Okay. So this is what is happening. How can I rewrite this? Once again, let me take the signal. and create a function here. Okay. So, okay, if I'm able to parse the file, I return the value. That's fine. I'm not creating a chain here. I don't need to create this fancy chain, so there isn't any next. What should I do if I'm not able to parse the file? What should I do if the file is not a text file? I throw an exception. Actually, if you throw an exception in functional programming, every time you do this, a kitten dies, so you shouldn't. So what else I could do? This, right? And the second problem is that if you use null pointer in functional programming, also the mothers of the kitten die. So no good, okay? So what's the third option? The third option is saying, with the file system, the actual behavior of this function. This function may or may not return a result, okay? This function may optionally return a result. So it should return a string, but it should return an optional of a string. Okay? So what I'm doing here is wrapping this result inside an optional, otherwise returning the empty optional. Okay? And I can do this with the other parser. So I will have the presentation one, the audio one, and the video one. Okay? Yeah. So what can I do now? I can put again this function into a stream. So I could do something like this. So I start with the text, then I add the presentation one, and then I add the audio one and the video one. Okay? There's a small problem here. The Java compiler is not smart enough to do type inference here to figure out which is the type of this stream. So I need to give it a little help. And here I'm saying explicitly that this is a stream of function from a file to an optional of a string. Okay? That's all. So what can I do here? I can try to apply the file to all this function in the stream. So I can do this. So I have a single function and I do apply passing the file. Okay? At this point, I have converted the stream of function into a stream of optionals, right? So I only want to take the optional that actually returned the value. So I will filter out the others. And so I will filter I will take only the present one, the one that contains a value. And then I take the first result, okay? What's the type of the object that I have at this point? Optional of what? Not really. At this point, I have an optional of a string. Why? Because at this point I have an optional, but find first also return an optional, wrapping the value, because the stream could be empty, and then in that case, the find first will return an empty optional. So since find first also wraps the result inside an optional, I have an optional of a string. Okay. What I have to do now is just flattening this to level optional because I don't need it. And there is a very easy way to do this. I just flat map passing the identity function. Okay, that's all. And at this point, I have the optional of the result. And I can unwrap it, and otherwise, yes, I shouldn't do this, of course, but otherwise I will throw an exception or return another value. Okay? And that's all. Let's try to print this out. Okay, same result. So I have another question for you. What do you think that is happening here? I have for parser, okay. So and I'm apply this function to all the 4 parser. So I'm apply this function to the parse text, the presentation, audio, and video. Is this true? Or let me rephrase. Am I calling the parse video function? Why not? Okay, because of laziness. Okay, correct. So this is just to say that it's exactly the same behavior of the other implementation. I'm not losing performance. I'm not doing any unnecessary job. Okay. Let's give a look at the interpreter pattern. So here I wanted to create an interpreter of an expression in reverse Polish notation, not because I'm a fan of this particular notation, but only because it's easy to parse it using a stack. Okay, so to put at work the interpreter pattern, I created this expression that is interpreted, okay? And then, as usual, I have different implementation. I have the add expression that performs an addition, of course, the subtract one, the product one, and then I have the number that it's interpreted like a number, so it just returns the number itself. And then I have a lookup method to resolve the different type of operation. Okay, that is this one actually. And then I can finally use this interpreter pattern, putting all the expression into a stack. So if I'm parsing an operator, I pop the right and left value on the stack, I perform the operation aggregate into 2, and I put the result back on the stack. Otherwise, I will put the number as it is. Okay? So let's try to give this a run. And the result is 12 because 7 minus 3 is 4, 2 plus 1 is 3, and 4 multiplied by 3 is 12. That's all. Okay, so the reverse Polish notation is just a simple way to nest the operation without using parentheses. Let's try to do exactly the same thing. So first of all, I have to encode somewhere the operation that are allowed in my expression. Okay, so I have to create a dictionary of this operation. So I can just maybe put them inside a map, right? So the map of operation is a map from a string that is the symbol of the operation, from the operation itself, the function applying that operation. So it's an int binary operator, okay? Because it's an operator working on 2 int and producing a third one. Okay, it's this operation. Okay, so let's create my map. Okay, and then I can populate this map. So when I find the symbol plus, I should add A and B, of course. And of course, I have to do something similar for minus and product. Okay. So let's try to rewrite this now. So I don't need this fancy expression anymore. I can just have integer on my stack. And what I can do is that now, at this point, I have a symbol. I have to figure out, by the way, I'm not doing any error check, nor in this version, neither in the Gang of 4.1, just for simplicity. I need to know if this is an actually operation or not. So I will just try to get it from my map. Whoops. Okay. And in case it is an actually operation, I will apply it. So I will get the 2 values from the stack, and I will combine them by using the operation. Okay? And otherwise, I can just put my integer on the stack. I don't need this interpret at all. Okay. And now I'm ready. And this should produce the same result. Question? Okay. Okay, I have 5 minutes for the last one. That is the visitor. Okay. So let's start. Oops. Let's start from the Gang of 4 example as usual. So I have a set of shapes. I have a square, a circle, and a rectangle. Okay, and I want to create 2 functions. One calculating the area of these figures, of a list of these figures, and one calculating the sum of the perimeter. Okay, so I instrumented my object by implementing this element method. By implementing this, they accept a visitor, okay? And the visitor knows how to visit specifically a square, a circle, or a rectangle, okay? And then I can have different implementation of the visitor. One implementing the area. So if I'm visiting a square, of course, this will be the result. If I'm visiting a circle, this will be the result, and so on. And the same thing for the perimeter, okay? And then I can finally use this visitor to accept one by one my figure and sum their area or their perimeter, okay? So let's try to run this, and this is the result for this list of objects. Let's try once again to do this. So let me take my domain and move this here. I don't need this stuff anymore. I don't need this fancy stuff anymore. I'm just getting the pure domain. So this is the square. And this is the circle. and this is the rectangle. Okay. And the functional version of the visitor pattern is the pattern matching. Of course, you don't have pattern matching in Java, but I created a quite simple class providing a very simple DSL to do some fancy pattern matching based on the class. Okay, so you have this function, and you define on a given class which function you want to apply. Okay. It's easier to see this at work. So I created this. And now I want to create the function that calculates the area of these different shapes. So this will be a function from an object to a double. Okay, it's the area, and this the. Okay, so I have this object that is an instance of this class. And what I can do on this, I created a very simple DSL. So when you say on square, okay, then the type inference of Scala of Java is able to understand that this S is a square. So I can say S side by side. Okay? Very simple. So when this function is passed with a square, it will apply this function. And then I can fluently add more function to my pattern matching utility. Okay? So I can say that when I'm passed with a circle, then I will return the area of the circle. Okay, and same thing for the rectangle. Okay, so I have a function that calculates the area of these three shapes. How I can use it? I have my list of objects. Okay, and then yeah, I just put these figures into a stream. Okay, I map using this function, right? So I'm transforming each shape in the double representing its area, and then I can do another reduce to sum all the area, right? And I can try to print this result. And I obtain exactly the same result as before, right? So yes, I'm a bit out of time, sorry. If you have a question, I hope I can take one question now, or I can take more offline if you prefer. Question? Thanks.